Welcome back, everyone. It's Dr. Linder. In this next um, series, we're going to be looking at cholesterol synthesis. And a huge part of the population, I'm going to say at least 20%, if not more, are taking a cholesterol or anti-lipidemic medication called a statin drug. Statins are typically taken at night. Statin drugs are medications that affect the liver and the liver's ability to produce cholesterol. The liver makes cholesterol primarily in the evening, which is why statins are supposed to be taken at night and not in the morning. And of course, should be avoiding grapefruit or grapefruit juice with statins. Um, Now, think back to the cell and the cell membrane. The cell membrane does require cholesterol. The brain requires cholesterol. We haven't gone over this yet, but I'll plant some seeds here. We have sex hormones. When we cover endocrinology, we'll go over some of these sex hormones like testosterone, estrogen, progesterone, testosterone, progesterone. These are steroid based. If you look at cholesterol, right, these are all steroid based. We need cholesterol. We need to make those sex hormones, we need cholesterol. Simple. So for healthy cell membranes, we need cholesterol. So you have to be really, really careful when using statins. What statins do, it takes acetyl coenzyme A, acetyl CoA gets converted to HMG CoA. Now, HMG CoA is supposed to be converted to mevalonate. And you don't have to memorize these steps. I just want you to understand. Mevalonate goes to farnesyl pyrophosphate, to squalene, and then to cholesterol. So this is the cholesterol pathway. When people take a statin drug, statins are blocking this enzyme that we see here crossed out. Statins block an enzyme. Remember, I said anything that ends in ACE is an enzyme. The enzyme is called HMG CoA reductase. You're trying to reduce HMG CoA into mevalonate so that you can get cholesterol. But if you're taking a statin and you block this enzyme, you downregulate everything below that line. You downregulate or reduce it. So we can see that this is how cholesterol is reduced. When cholesterol is reduced, we're going to affect hormones. We're going to affect your antioxidants. But look to the right. Look what else can get affected and reduced if you're reducing the body's ability to produce cholesterol by taking a statin. You also reduce the body's ability to produce CoQ10. And what is CoQ10 used for? Energy production because of the electron transport chain. CoQ10 is needed by the electron transport chain, as is iron. And that's why when people have an iron deficiency anemia, they have ulcers, when a woman is menstruating during that time of month and is losing an excessive amount of blood, she may be tired because of the reduction of iron. And if you don't have iron, you're anemic. And if you're anemic, you have fatigue because you can't produce ATP. Where do we have the most mitochondria? Because wherever we have the most mitochondria, that's what's going to be affected by little iron and CoQ10. So let's think of where do we have the most mitochondria? Well, it would make sense that we would have them in parts of the body which are requiring energy production, like muscles. What muscle is constantly beating and contracting? The heart. So you can get these cardiomyopathies. You can get heart disease. What about the brain? The brain is always working. So when you have these CoQ10 deficiencies and you get mitochondrial dysfunctions, you can get cognitive decline or dementia-like symptoms. In fact, one of the new black box warnings on statins is dementia-like symptoms or cognitive decline. Most likely a combination of lowering cholesterol, because the brain requires 20% cholesterol, if not more, but also affecting the mitochondria for energy production due to lack of CoQ10. So you get the heart involved, you got the brain involved, and then when muscles hurt, the term algia means pain. My means muscle. So myalgia means muscle pain. And if you have fibromyalgia, we have to start thinking about mitochondrial dysfunctions and looking at CoQ10. Now, the mitochondria requires just not CoQ10, it requires iron, it requires B vitamins, it requires magnesium, it requires manganese, it requires omega-3s, fish oils. There's lots of things that the mitochondria requires to function properly. I just wanted to introduce to you a concept between iron and CoQ10 and statins that is something that's happening uh, a lot more regularly than we may be aware of. And since my students here are going to be getting into healthcare, I'd like to introduce this concept because you can really help a lot of people by, if they do need a statin short term, then the pharmacist or the doctor should also let them know about CoQ10. I love taking CoQ10. I suggest many of my patients do it. Um, CoQ10 is called ubiquinol or ubiquinone or ubiquinol. They come in two different flavors. Ubiquinol is a little bit more expensive. They've done lots of studies with Parkinson's disease and using very, very high dose ubiquinol or CoQ10 with these patients with Parkinson's to help. One of the other things to be careful of with statins is that it can increase glucose levels. It can increase glucose. So something to monitor.